So today we're going to do 7.1, which is a little bit of review from Algebra 1 and Algebra 2. And so we're going to go ahead and get started. And we're going to talk about substitution, solving systems graphically, and the elimination method. And so the solution to a system of two equations in two variables is going to be any ordered pair of real numbers that is a solution to both equations. And so in Algebra 1, you talked about linear systems of equations and how to solve them using graphs, substitution, and elimination. And then in Algebra 2, you went on to look at some that weren't necessarily linear and how you solve those, which looks a little bit differently. So to get started, just to review a little bit, using substitution, the whole idea about substitution is that you're going to take one variable and plug it into the other one. In this case, it looks like y is going to be the easier variable to solve for between the two equations. So solving for y, I would have negative y equals 2x. Nope, not 2x. It would be 10 minus 2x. And then when I go in to get rid of the negative, I would have y equals negative 10 plus 2x. So then I will go in to substitute, and I will take what y equals and I will plug it in for y. So this would give me 6x plus 4 times negative 10 plus 2x should equal 1. And so then I have 6x minus 40 plus 8x equals 1. And so 6 plus 8 is going to be 14x will equal 41. Yes, fractions are going to happen. We work through them even when they're not our favorite. And so in this case, we will divide both sides by 14. And then I get that x equals 41 over 14. Okay. So then to finish solving this one, I still need to find what y is. And so I will take my solved equation for y. So I have y equals negative 10 plus 2 times 41 over 14. Well, the 2 and the 14 will go to 7 in the denominator. And so this is going to be approximately 6 and 6, not 6. It's going to be 5 and 6/7. Okay. So then I would have y equals, well, subtracting those two is going to leave me with 4 and 1 over 7. Negative 4 and 1 over 7. And so that gives me the ordered point when I put them together, which is 41 over 7. Not 41 over 7. I'm sorry. That's going to be my 41 over 14. And then I want them both either in mixed numbers or in improper fractions just to be consistent. So 4 times 7 is 28, plus 1 is 29 over 7. It needs to be negative. So this would be my final answer. Okay. So substitution is I'm taking one variable and plugging into its equivalent expression into the other in order to go through and solve the problem. So substitution is used especially when you don't have a linear system, because our elimination doesn't work well, and graphically only works when you're allowed to have your calculator. It only works well when you have your calculator. So in this case, going in, it's going to be easier to plug this y into that one or vice versa. It doesn't really matter in this case. So I get that 8x equals x squared plus 6x. Well, now I have a quadratic equation that we spent a lot of time with back in chapter 2. So I need to get everything to one side. So I'm just going to move the 8x this time because it makes it a little faster. So I'd have plus 6x minus 8x, which leaves me with x squared plus, not plus anymore, it's now going to be minus 2x. So when I factor out the x to solve for this one, which is what makes more sense in this case, I can then set each factor equal to 0. And in this case, I have two possible solutions. So because of that, I need to find both possible y values. So when I plug in x equals 0, in that case, I'd have y equals 8 times 0, which in this case is 0. And then, so I would have the point 0, 0. And then if I plug in x equals 2, I have 8 times 2, which equals 16. This is when x equals 2. Then I have the point 2, 16. And both of those coordinate values are my solutions to this system of inequalities, because we can't have more than one answer if we don't have a linear system. Linear at most can have one answer, but it also could have no real solution, or it could have infinite, which we'll look at in a little bit. So, going to talk about elimination. Elimination is when you want to add or subtract your polynomials together in order for things to cancel out. So with that, in this case, none of them just simply add or subtract together easily, but I noticed that my y's have different signs on them, and so that'll make it easier for me to deal with multiplying them to get rid of them. So in this case, I need to multiply the whole entire top by 2, not by 2, by 3, to end up getting it to cancel out with the denominator. So I would have 9x plus 6y equals, I need to multiply it by the whole top, including the 12, so it'll equal 36. And so my other equation, I needed to multiply the whole equation by 2 to make them cancel out, since 6 was my common factor between them. And so I would get 8x minus 6y equals 66. So now I can just go and add them up together. And so I get 17x, my y's canceled out to 0. 6 plus 6 is going to be 2, carry the 1, that's going to give me 102. So the last thing I need to do is go and divide by 17. And so 102 divided by 17 is equal to 6. So in this case, x equals 6. I still need to find the y value. So pick an equation. It doesn't matter which one. There's not a benefit. Pick the one you prefer more. So I'm going to pick the top one just because it's smaller numbers. So I'm going to have 3 times 6 plus 2y equals 12. So that's going to give me 18 plus 2y equals 12. Subtracting 18. I'm going to have 2y equals negative 6. Dividing by 2, I get that y equals negative 3. So my point is 6, negative 3 for this system of equations. So when you have a no solution with a system, we need to end up finding out what that looks like. And so with these, graphically, it means there's no intersection. And so if you solve both of these for y and went to graph them, they would have no intersection at all. But with elimination substitution, we have to recognize what do they look like when they cancel out. So in order to get this one to work, let's go ahead and I'm going to choose to use elimination. And so in this case, I can get my y's to cancel out easily if I multiply the top one by 2. And just leave the bottom one the same. So the top one would be 6x plus 4y equals 10. My denominator will be negative 6x minus 4y equals 10. So right now, if I add my y's up together, they cancel out, but so do my x's. So in this case, I have 0 equals 20. This is not a true statement. So this one is a false statement. Because it's false, there is no solution. If it was a true statement, that means my two equations I gave you were the exact same thing, and that means there's infinite solutions. So just so we can review what an infinite solution looks like, let's do one of these. These can also still come up with substitution. Both variables cancel out. You're left with a true statement or a false statement, and that lets you know which type is which. So in this case, let's multiply the top by 3, because that's going to let my 9's cancel out, but it needs to be negative because of that denominator, since all my signs are the same. So I'd have negative 9x minus 18y equals positive 30. And the denominator will stay the same, not denominator, the bottom equation, plus 18y equals negative 30. So, in this case, everything ends up going to 0. You don't have to try and make a 0, 0 happen for an infinite solution, as long as you get what's called a true statement, which means you have the same number on both sides. So because of that, this one is infinite solutions. Which means every point that is on one line is on the other line. So with that, we're actually done, other than us looking at what it looks like to go and graph some of these. So let's actually I'm going to pull up my graphing calculator on my computer screen so you can see what it looks like. Okay, so what if we go, so I'll have to turn it on, even though on the computer I have to turn it on. So if I go to y equals and type in one of my lines, okay, so earlier we had the we had x squared plus 6x as one of them, and then I also had a 8x as the second one. So when you have your lines typed in, or your equations, they don't have to be lines, and you go to graph them, we want to make sure we have a good window, and I can see that stuff is happening over here, but I don't really have a great picture of it, okay? Obviously the two aren't going to intersect over here at the negative side of things. So I'm going to click on window, and I'm going to change my min to a -1, and then I'm going to change my max. I didn't have to go out too far, so I'm going to go to maybe 4 and see what happens. And then I didn't have to go too negative because of that picture, so I'm going to change y to -1. And because we already know what my y max was, I'm going to go to 18 because we already solved this system. It's going to take some more time to double check and see how those go. So I'm going to hit enter, make sure it's saved, and then hit graph. And so in this case, I can now see both of them, but it is pretty small scale. So let's go and use my calculate option. So I'm going to hit second and trace to calculate. And then going in here, I have the option for intersect, which is number 5. We haven't really used intersection yet. So I'm going to select 5. Okay, well, so let's go for this one up here. The one I know that they intersect is at it was 216. And so first of all, it says first curve. I'm going to make sure my two curves are different. So the first one says that one. So I'm going to go ahead and say yes and hit enter. And then it does change to my y2, even though it looks pretty close. And I'm going to hit enter. Now, it says guess. You're welcome to hit enter if you want. It does give me that my intersection is at 216 like I saw it was earlier. Okay? But we do have to be careful because one thing that we saw before is that I did have a second one. If I go and hit second, calc again, and then I choose my intersect option, okay, it is still going to give me some problems, okay. Oh, my screen froze. Okay, so if I go through and do the same process, I have my Y1, I hit enter. I have my Y2, I hit enter. If I hit enter on guess again, it's going to give me the exact same value it gave me before for Y. So I need to have a better guess. So if I change my guess to being 1 or 0, because that's what it looked like where the other intersection was on my screen, I know it's behind the word guess right now. If I hit enter on 1, it still gave me that other intersection. So let's change my window a little bit and just go from -1 to 1, and then go from -1 to 1. And so you're going to have to pay attention with it, because sometimes it's going to tell you, hey, this is the only spot, and it's not. And that window is still kind of rough, but let's go ahead and try and use it for the calc option. And so I'm going to need to hit 5, and then my first curve, it says my Y1 up there in that top left corner. And then if I hit enter, oh, my screen froze again. Give me one moment. Okay, so if I hit enter on second curve, now it changes that cursor for my guess. I do need to get as close to 0 as possible for that guess to actually show up. If we used the window we had earlier, so -1, 4, -1, and 16, when I would go to use it, it does look like it's really close to 0. I can see it's not at 1. So if, even leaving it on this window, if I did the intersection and went, so I have my x squared, my 8x, instead of my guess, if I went close to 0 instead, or even if I went for like 0.3 or 0.5, that one would kick back the intersection of 0, 0, because it will always give you the intersection that is closer. And so make sure you're careful with that when you're going through and using your calculator. So now you'll go online and work out your problem set for 7.1, and then tomorrow we will be on to 7.2. Let me know if you have any questions. I hope y'all have a great day. Bye, guys.